How's it going, everyone? Welcome. Eulier Gonzalez here. So, today let's take a look now at the global scope. Why the global scope and where exactly is the global scope? And finally, to get into the next chapter of the lexical scope with variables, specifically with let, cons, and now the hoisting. So here, over the series of videos, what we have talked about is, regardless of what JavaScript is, and everything that is around and inside it, right? So this was the chapter one, or the book written by Kyle Simpson, where he described is, well, what are the things that are outside of JavaScript. So for example, who makes that, who owns the legal trademark, the the commit that oversee that spec, what is the end goal of that commit, what is the process from that commit to include any proposal to spec, and because he wants to guarantee now backward compatibility, they provide these polyfills for those people that wants to live on the edge, so they can now implement these polyfills to make these new features browser safe, right? So, and also to understand that the JavaScript itself has different approach or paradigm, and how this JavaScript engines works, right? Pretty much like a compile language rather than a interpreter, despite that it is scripting nature, and this is based on an observable behaviors. And also the concern about JavaScript, if this is a fast language or not. Despite that, there have been good precedents that show that this is not the case. So for example, with ASM, and now with WebAssembly. So, and also to look at this from ES6, ES5, uh, this feature on the language, which is the strict mode, to set us to to define a set of rules that JavaScript developers must stick to this, to let the JavaScript engine to, or to have a good chance for the JavaScript engines to of running optimizations, of optimizing and running your code. This is pretty basic. That was the chapter one in that particular book, and also look at more in depth with the JavaScript in terms of uh, the basics. So how, what is a programs, what is a values, what is the type of value that we can have, primitive and objects and functions as well. How can we define those values, whether it's literals or variables, and also how can we now use functions in our programs, and because they now act as a value that we can pass around in our program, how they behave, right? Whether it's a procedure or a mathematical strict definition of a functions, and also how you can now operate with these values. So, for example, is how you can now compare those values, how you can transform those values or coerce those values, and how then you can organize your code in uh, JavaScript, all right? Whether it's as a function or a class or a model. And then looking at the low level features, all right, that virtually affect every line of code that we write. So, for example, is that how we iterate through a collections. So, what is now an iterator protocol? What is an iterable? And also, what is the what is a closure, which is a part of the function scope, which is part of the anatomy of the functions. Okay, and what is this closures? What is a scope? Which is a set of is a set of rules that allows to resolve if variables with it is reference. It is identified with it is reference before the code is compiled. And another feature of the function, which is the value of this, which this is something that you can provide, modify, or inherit, so to speaking, okay, anytime when you run that function, right? So you can have access to this value, aka you can modify this value, this data that is available at execution, because these functions can have access to this execution context. So also the features or the anatomy of objects, which is the prototype change, which is a way of how can resolve property name access along different objects that share a reference via this object prototype change. Okay, uh, so all of this is just to now understand that in this chapter or in this book, where we focus exclusively is on scope and closure, is to now understand that is to understand the importance of scope and closures by asking two questions. All right, is that how can we now make how JavaScript know in a particular statement that this is the set of variable that it can have access to. All right, and also is how now JavaScript handles names with this variables name, uh, variables with the same name. Okay, so in order to understand that, well, we need to at least set the common ground to say, hey, in any programming language, this is not exclusively for JavaScript, we do need to understand is the importance of working with variables, which after all they are containers that act inside, they act as a container in a program that allows to hold values inside of this, because we can have primitive and objects, and since the relationship between these variables between the function and this and the block scope uh, are determined by the scope rules, which happens before the code is executed. Once this is created, uh, it won't be affected by runtime conditions. And because functions now are values and we can define variables inside of functions, so no matter whenever we call this function in our code, the scope structures remains. And for that, well, we look at this is not theory. We look at the observable behavior of how JavaScript works in these two phases, which is similar at how compiler works. For example, like in classical compiler theory, you have now the lexical and the tokenizer, which is going to transform all of your source of text into meaningful tokens to the language, pretty much like you are uh, reading English or Chinese. If you do understand that, great. If you don't, syntax error for you, you know. Um, so, but the thing here is that this tokenizer or this lexing, right? And the difference between lexing is that how now the tokenizer is going to evaluate that token. Hey, if this token belongs to another token, or if it's part of another, or this different, or if this a different token. So, this then once that strings of token has been created, it's going to create now is the abstract syntax tree that have the structure of how this code look like, okay, and then it's after that usually generate code, and it is very specific to the language and to the platform. So because now of JavaScript, when it comes to analyze syntax errors, early errors, and scope or hoisting, right? It's work not the way how we think that interpreted language analyze that stuff. It works pretty much like a compiler does, where it passes this check first before the code is executed. So to understand this hosting nature, okay, is also to look that what's going on in this scope, in this hosting. So because it's also important to understand that not only when we define the variables related to functions and block, but also is when we assign those values, whether this is a target or a reference value. The thing here is that when we look at the lexical scope, we illustrate the lexical scope, it's like having a conversation this in two phases, whether it's a compile before the code is executed, and then at the execution with the engine. So the compiler first have a conversation with the scope manager to determine is the variables named reference or the identifiers, okay? And once that is done, again to evaluate is early errors or name. Yeah, so early errors of syntax errors or scope hoisting, okay, and then it's going to evaluate your code, aka it's going to assign those values to that, which is a conversation that the JavaScript engine has with the scope manager. And because you can now have is different variables nested in different scope, and in order to understand this, well, each one of those scope, whether it's a function and block, most likely, define a set of rules, define a set of define as a way of how now this container is going to behave, aka variables, right? Whether it's let, cons, var, and how they're going to have access lexically. So this scope nested structure, which is determined, or the relationship between these nested scope structures is determined by it is reference that each one of those scope has, which is an internal property known as outer env, that points to the outer environment known as the scope change. So this is scope change, right? That allow us to lexically have access to the outer variables. Sometimes when you put now names with the when you put now variables with the same name, shadowing occurs, aka so if you define here a variable, let's say salute, all right, and then you define in a different block nested scope another variable here salute, the same name, so you can have access to this lexically. You just only have access to this. You can of course have access to these outer variables by creating a copy, but that's not lexically. So this there is another places where we can define a scope or imply a scope, which to me was quite mind bending when I realized that, which is you can so parameters in your functions create now in a scope, and then you can have now is um, uh, even closures in there. The TLDR is that avoid shadowing uh, parameters with local variables. That's not a good practice. I mean, it's a foot gun, sort of speaking. That's one, and the other is the function names declaration as well as the arrow function, right? So both of them create scope, all right? The behavior is different, not in scope, but the property that it can have access to, as well as some of these functionality. So, for example, is they are anonymous, so they are lexical anonymous. So you can have access to, unless you define as a function expression. In the case of a arrow function expressions, and with functions named and an arrow function, this is just more opinionated. Okay, uh, the point is that it is much meaningful when you describe when you use function names when doing this data pipelines or data treatment or data flows to describe once you get your data how it's going to end up. Okay, whether if you have a collection of values and that you apply a map, a transformation to each one of those elements, and then you want to filter them. This work great for synchronous values, all right, which is great. And how do you handle now for eventual values, all right, single eventual values with promise, or collections of eventual values like observables. Again, this goes beyond the scope of today, but it turns out that this uh, is highly opinionated. I do agree with that because it makes a lot of sense when it comes to know how the things works. All right, and then we also look another place where we can put our variables, which is the global scope. So this global scope, which is a way of how now different JavaScript files can cooperate at runtime and act as a single program in the browser environments. There are three ways so you to do this. All right. So you either is define this as an ES6 model, and anytime you use the import key, you're going to now include this another file. And if you use another import key, another file, and as you can see, you know, the problem with this that you want to have is the waterfall cascade, um, which can slow down your application. The traditional way of making this is using something known as the UMD, which is just a fancy way to now enclosing this in a so enclosing all of your functionality in a function scope, for example, all right, and inside of this scope you define is the different models that they can communicate inside of it, and then now ship that, so stringify, ship that to the browser to be executed as perhaps as an immediately invoked function expression. Okay, uh, and the other is through sharing variables in the global scope. So this global scope that is specific to environments. So you have now is the browser and how the browser global environment works. When you define is variables inside of that, or even when you define functions inside of or variables inside of functions without the var keyword, how also you can have access to ID elements, DOM elements via its ID through the scope. That's to me was mind bending. Absolutely. Uh, we also have another runtime like the web workers where you can have access to the DOM. It just has a different JavaScript instance where the global you can have access is self, as well as some web APIs to do that. So, for example, like Navigator. Another place is the JavaScript Dev Console or RELP, uh, the ES6 modules, where here you can think of this like a function scope wrapping around your models because there is no global this to have access to. And the other is the node environments where using CommonJS, which is a way of how you can organize your code, you can have access via the models.export in the name of the variables, or now via the global this, all right, which is a property that is exposed now to that. So that that makes a lot of sense. You know that this is good. We know, and that explain a lot of the times of how can we have access to this, okay, and how different objects can cooperate, because at the end of the day is that how can different all how 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 different environments uh, can cooperate here, or how different environments have a common place, the global scope to cooperate. Okay, so we have a window, self, and global, and this ugly new function trick. So for example, that's a lot of different ways to try to get to these global objects. Each has its pros and cons, and why not introduce yet another? As ES6 2020, JavaScript has finally defined a standardized reference to the global scope object called the global this. So subject to the residency of the JavaScript engine your code runs in. You can use the global this in place of any of those other approaches. We could even attempt to define a cross-environment polyfill that's safer across pre-global this JavaScript environment, such as this. Hey, is the global? This is a polyfill. If the global this does not exist, uh, if the global exists, return the global this. Is the global exists, return the global. If this is a window, return the window. If this is self, return the self. Otherwise, you can now return whatever it is on this via the function. Few, that's certainly not ideal, but it works if you find yourself needing a reliable global scope reference. The proposed net global this was fairly controversial while the feature was being added to JavaScript. Specifically, I and many others felt that this reference in this name was misleading. Since the reason you reference this object is to access the global scope, never to access some sort of global default this binding. There were many other considered, but for a variety of reasons, rule out. Unfortunately, the new chosen end up as the last result. If you plan to interact with global scope in your programs to reduce confusion, I strongly recommend choosing a better name, such as the laughable long but accurate the global scope object used here. So, the global scope is present and relevant in JavaScript programs as a way to know that this is a place where different files, different programs can cooperate, okay, and how you can organize your code. Still, as our code proliferates more and more beyond the confines of the browser, it is especially important we have a solid grasp on the difference in how the global scope and the global scope objects behave across different environments. With the big picture of the global scope now sharper in focus, the next chapter again descending to the deeper levels of lexical scope, examining how and when variables can be used. This is how variables can be used. By now, you should have a decent grasp of nesting scope. From the global scope downwards, called a program scope change. By just knowing which scope a variables come from in only part of the story, if a, exactly knowing which scope a variable come from is only part of the story. If a variable declaration appear past the first statement of a scope, if a variable declaration appear past the first statement of a scope, how will any reference to that identify? Okay, if a past reference, if a variable declarations appear past the first statement, okay, where it produces a value of a scope, how will any reference to that identifier before the declaration behave? What happens if you try to declare the same variable twice in a scope? This is two questions here we're going to ask. Okay, so if a variable declarations appear past the first statement of a scope, how will any reference to that identifier before the declaration behave? And there is a lot of jargon here if you're not familiar with. So what happens if you try to declare the same variable twice in a scope? Two questions. So what happens when you try to declare the same variable twice in a scope? And the other is that if a variable declarations appear past a first statement of a scope, how will reference to the identifier before? How will any reference to that identifier before the declaration behave? So JavaScript particular flavor of lexical scope is rich with nuance in how and when variables come into existence and becomes available to the program. When can I use a variable? At what point does a variable becomes available to use within its scope? Okay, when can I use a variable? At what point does a variable becomes available to use within its scope? That's a good question. At what point those a variables becomes available to use within its scope? There might be seen an obvious answer after the variable has been declared or created, right? But not quite. So for example here, the first instance or the first statement of that identifier, how is now that JavaScript solve this reference here? This code works fine, and you might have seen or even write code like it before. But did you ever wonder how and why it works? Specifically, why you can't access the identifier greetings before it was defined to retrieve an execution of function reference, even though the greeting function declaration doesn't occur until line 4. Recall chapter 1 points out all the identifiers that register to the respective scope. Exactly. In this case, during the compile time. So in other words, this identification of the or this registration of identifiers, all of this happens is before the code is executed. Okay, so moreover, every identifier is created at the beginning of the scope. It belongs to every time that scope is entered. So moreover, every identifier is created at the beginning of the scope. It belongs to every time that the scope is entered. The term most commonly used for a variable being visible from the beginning of its enclosing scope, even though its declaration may appear further down the scope, it is called hoisting. So hey, what is hoisting? Is the is is a term used to is a term used is a term used for a variable being visible. Okay. It's a term used for a variable being visible in an enclosing scope. Exactly. So is so hoisting. The term most commonly used for a variable being visible. Okay, is the visibility of a function. Okay, is the visibility of a what is hosting? Is the visibility of a variable uh, at the beginning of its scope. Mm, is the is the visibility of a variable at the beginning of its scope, even that declaration happens further down that scope. Mm. hmm But hosting alone doesn't answer fully. Uh, exactly. It's like okay, this is it's a feature, okay. But it doesn't answer me is that how that works. Alone doesn't fully answer the question. We can see an identifier called greeting here from the beginning of the scope, but why we can call greeting function before it has been declared? In other words, how does the variable greeting have any value? The function reference assigns to it from the moment the code start running. The answer is a special characteristic of formal functions declarations called function hosting. So when a function's declaration name identifier is registered at the top of its scope, it is additionally auto-initialized to that function's reference. So that's why the function can be called throughout the entire scope. One key detail is that both function hosting and var flavor variables one key detail is that both function hosting and var flavor variable hosting attach their names identifier to the nearest enclosing function scope, or if none, the global scope, not a block scope. Exactly. So it is going to attach its name identifier to the nearest enclosing function scope, their variables and their function, or the global scope, not the block scope. Notes. Declaration with let and con still hoist. See the temporal that's on discussion later in this chapter. But these two declarations forms attach their enclosing blocks rather than just an enclosing function as with var and functions declaration. See scoping with block in chapter 6 for more information. Hosting declaration versus expressions. But again, the hoisting is the visibility of a variable in a particular scope, even after that, even if the variable's definition happens further down that scope. Mm. Mm-hmm. But it's the visibility here, and this visibility that is uh, that is that is defined by the function. By it's defined by the scope here. Exactly. So this is a feature of the scope here. The function scope, not the block scope. Mm. So now we're talking is uh, the okay we okay the features of functions, the features of function. Good, good. So not only that, this so not so closure and scope is a feature of function. Okay, uh, similar to the this value. All right. So things started to make a little more sense. Hoisting declaration versus expressions. Function hostings only applies to formal functions declarations, especially those which appear outside of blocks and see FBI in chapter 6. Not to function expression assignment considered. Function hosting only happens at formal functions declaration. Exactly. In line 1. So line 1 greeting here, it say, hey, this is a type error because it's fine that you define this functions declaration as a value in a variable. This doesn't work. But the kind of error throw out is very different. It say this is a type error. It's not a syntax error. Means we're trying to do something with a value that is not allowed. Depending of your JavaScript environment, the error message will say something like undefined is not a function, or more helpful, greeting is not a function. Depend of your JavaScript function environment. So in this case, if we say greeting, we say var greeting is equal to function greeting, despite that we are defining here as it is as a function name expression. Say hello. It's a now a type error and say greeting is not a function. So this identifier type error. Look at this, but this is a different error here. It's not about reference. It's not about reference. It's about now the type of this value here. Exactly. Notice that the error is not a reference. It's not a reference error. JavaScript isn't telling us that it could find exactly. JavaScript is telling us, hey, I could find this, but it's not a function. Okay. Okay. So it means that this hoisting or this this analysis that happened here, it say, hey, it is telling us the greeting we found was found, but doesn't hold a function reference at that moment. Exactly, this was found, but it doesn't hold any function reference at that moment. Only functions can be invoked, so attempting to invoke some non-functions value result in an error. But what does greeting hold, if not the function's reference? That's a good question. In addition to being hosted, so if you say something like this, you say, hey, again, this is an error here, and I'm gonna tell you that. So again, I could find that, but the value is not what you mean. So in addition to be hoist, variables declared with var are also automatically initialized to undefined at the beginning of their scope. Again, the nearest enclosing function, okay, and the nearest variable definitions are hosting with undefined. Again, and it is enclosed, and it is close, and it is nearest enclosing scope. Mm-hmm. Or the global in this case. Once initialized, they are available to be used. So, for example, if you say something like this, you will say that this is now an undefined, because that's right. Okay. And once initialized, they are available to be used, assigned to retrieve from, etc., throughout the whole scope. So on that first line, greeting exists, but it holds only the default undefined value. It is not until line 4 that greeting get assigns the function reference. And pay close attention to the distinction here. A function declaration is hosted and initialized to its function value. Again, call function hoisting. Mm-hmm. Exactly. A function declaration is hosted and initialized to its function value. So in other words, this this hosting is the visibility that a variable or function declaration have in its scope, despite that the definition happens further down that scope. Okay, so it's the visibility that is the visibility of a variable of a function has at the beginning of their scope, even if that declaration happens later on in that scope. Mm-hmm. Okay. Okay. Again, this is a feature from variables and function declaration. But this is the definition here. Any subsequent function expression assignment to the variable don't happen until that assignment is processed during runtime. Any subsequent function expressions assignments to the variable don't happen until that assignment is processed during runtime execution. In both cases, the name of the identifier is hosted, but the function's reference associated it handles an initialization beginning of the scope unless the identifier was created in a formal function declaration. This is to describe is where can I use variables, hosting declarations, declaration versus expression, variable hosting. Mm-hmm. And let's look another example of variable hosting here. Through greetings isn't declared until line 5 here exactly. Through greeting isn't declared until line 5. It is available to be assigned to as early as line 1. Why? There is two necessary part of to the explanation. The identifier is hosted and it is automatically initialized to the value undefined from the top of that scope. Using variable hosting of this sort probably feels unnatural. And many readers might rightly want to avoid relying on these programs. But should all hosting, including function hosting, be avoided? No, I don't think so. We'll explore this different perspective on hosting in more detail in Appendix A. In Appendix A, which is this one. In Appendix A. Hosting functions and variables. Chapter 5 articulated both function hosting and variables hosting. Since hosting is often cited as a mistake in the design of JavaScript, I wanted to briefly explore why both these forms of hosting can be beneficial and should still be considered. Give hosting a deeper level of consideration by consider the method of executable code first, function declarations last, and semantic placement of variables declaration. Function hosting. Executable code first and function declaration last. Exactly. Give hosting a deeper level of consideration by considering the merit of executable code first and function declaration last. Semantic placement of variables declaration. Okay, semantic placement of variables declaration. To review these programs work because of function hosting. Mhm. The function declaration is hosted during compilation. But again, this is the way of how this is now being organized. Go organization. The function declaration is hosted during compilation, which means that getStudent is an identifier declared for the entire scope. Additionally, the getStudent identifier is auto-initialized with the function reference. Again, at the beginning of the scope. Why is this useful? The reason I prefer to take advantage of function hosting is that it puts the executable code in any scope. Wait, what? Why is this useful? The reason I prefer to take advantage of function hosting is that it puts the executable code in any scope at the top and any further declaration function below. This means it is easy to find the code that will run in any given areas rather than having to scroll and scroll hoping to find a trailing. Mm-hmm. Making the end of a scope function somewhere. I take advantage of this inverse position in all levels of scope. So for example, like this. When I first open a file like that, the very first line is executable code. Exactly, executable code. And in kickoff it is behaviors. And then the declaration. So that's very easy to spot on. Then if I ever need to go find and inspect getStudent, I like that its first line is also executable code. Only if I need to see the detail of something do I go and find its definition down below. In other words, I think function hosting makes code more readable, though a flowing, progressive reading order from top to down. Variables hosting. What about variable hosting? Even though let and const hoist, you cannot use those variables in their TDC. See the chapter 5. So the following discussion only applies to var declarations. Before I continue, I will admit, in almost all cases, I completely agree that variable hosting is a bad idea. While the kind of inverted ordering was helpful for function hosting, here I think it usually makes go harder to reason about. But there is one exception that I have found somewhat rarely in my own coding. It has to do with where I place my var declaration inside of a common JS model definition. Here's how I typically structure my model definitions in Node. So you have your models, right? Require, public API, and then private implementation. Notice how the catch and all the data variables are in private section of the model layout. That's because I don't plan to expose them publicly. So I organize the model so they located alongside of the main implementation details of the model. But I have had few rare cases where I need the assignments of those values to happen above before I declare the exported public API or the model, for instance. The object.assign. Okay, the object.assign is to say, hey, I want to, this, the object.assign is object.assign is working with the prototype here. Object.assign, right? Object.assign says static method copy all enumerable own properties from one from one or more sources. Copy all enumerable own properties. Copy all enumerables own properties from one or more sources to the target objects. Okay, and in return a modified target object. Okay, so it's like enhancing. It's like enhancing here. Okay, okay, it's like enhancing here with this new reference. Object.assign. Okay, so from this target here, which is the model.export, I want to now is attached to the global API or to the global scope is all of this object as it is. Mm-hmm. And notice how the catch and other data variables are in private sections of the model layout. That's because I don't plan to expose them publicly. I organize the model so they have relocated alongside the other hidden implementation detail of the model. But I have a few rare cases like this. I need the catch validation, I need the catch variable to have already been assigned a value because that value is used in the initialization of the public API, the bind, partial application. Should I just move the var catch up to the top above this public API initialization? Well, perhaps. But now it is less obvious that var catch is a private implementation detail. And here's a compromise I have somewhat rarely used, like catch. Use here but declare below. See what variable hoisting? See the variable hoisting here? I declare the catch down. It belongs logically, but in this rare case, I have used early up above in the area where it is initialized is needed. I even left a hint at the value that is assigned to catch in a code comment. That's literally the only case that I ever found for leveraging variable hosting to assign a variable early in a scope than it is declaration. But I think it is reasonable exceptions to employ with cautions. In the case of var, speaking of variables hosting, and let's have some real talk about a bit of var, a favorite villain devs love to blame for many of the woo of JavaScript development. In chapter 5 we explore let cons and promise. We have revisited where var falls in the whole mix. As I lay out the case, don't miss var was never broken. Let is your friend. Oh, as I lay out the case, don't miss var was never broken. Less is your friend. Cont has limited utility, and the best of the buzzword is var and let. Don't throw out of var. var is fine and works just fine. It's been around for 25 years and it'll be around and useful and functional for another 25 years or more. Claims that var is broken, deprecated, outdated, dangerous, or ill-designed are bogus. Bandwagoning. Wagoning. Bandwagoning. Ill-designed. Bandwagoning. It's an international relationship occur where a state aligns with a stronger adversary power and concedes that the stronger adversary turned partner disproportionately gains in the spoil they conquer together. Bandwagoning. mm-hmm. How do you say bandwagoning in Spanish? Bandwagoning. Okay, that's new. Subirse al carro, man. Okay. Get into the chopper. Bandwagoning. Okay. This is the get into the chopper. Okay. Okay. Bandwagoning. Does that mean var is the right declarator for every single declaration in your program? Certainly not. But it still has its place in your program. Refusing to use it because someone on the team choose an aggressive linter option that chokes on var is cutting off your nose to spit your face. Okay, now that I got you really riled up, let me try to explain my position. For the record, I'm a fan of let. Block for block scope declarations. I really dislike the TDC and I think that was a mistake. But let itself is great and I use it often. In fact, I probably use it much more than I use var. Cons and T constantly confused. Constantly confused. I'll be right back. And we're back. So constantly confused. And cons and other on the hand, I don't use as often. I'm not going to dig into all the reasons why, but it comes down to cons not carrying it its own weight. That is, while there is a tiny bit of benefit of cons, in some cases that benefit outweighed by a long history of trouble around cons confusion in a variety of language before it ever showed up in JavaScript. Okay. So for example, Java. Cons pretends to create values that can be mutated, a misconception that is extremely common in developer community across many languages. Whereas, exactly, cons pretends to create values that can be mutated, a misconception that is extremely common in developer community across many languages. Whereas what in reality what it does is to prevent reassignments. So for example, like this, but you can mutate that. So using accounts with a mutable value, like an array or object, is asking for future developers or readers of your code to fall into the trap you set, which was that they either didn't know or sort of forgot. The value immutability isn't at all the same thing as assigning immutability. You just don't think we should set those traps. And the only time I ever use count is where I am assigning an already immutable value, like a primitive 42, hello friends, and when it's clearly a constant in a sense of being a name placeholder for literal values, for semantic purpose. So that's what count is best used for. That's pretty rare in my code though. If a variable reassigned were a big deal, the counts will be more useful. But variables reassignment just isn't the big a deal in terms of causing bugs. It is mutability, mutating that value. There is a long list of things that leads to bugs in programs, but accidental reassignment is way down the list. Combine that with the fact that const and let are supposed to be using block, and blocks are supposed to be short, and you have, in theory, but that's good, and block are supposed to be short, and you have a really small area of your code where a const declaration is even applicable. A const on line 1 on your 10 line blocks only tells you something about the next 9 lines, and the thing it tells you already obvious by glancing down on the 9 lines. The variable is never on the left hand side of the variable is never on the left hand side of an equal is not reassigned. That's it. That's all count really does. Other than that, it's not really useful. Stack upon against the significant confusion of value versus assignment immutability. Count lose a lot of its luster. Luster. Meaning? Soft reflected light. Sheens. Oh, luster. It is brightness. Okay, luster. A let or var that's never reassigned is already behaviorally a constant, even though it doesn't have the compile guarantee. That's good enough in most cases. And var and let. In my mind, count is pretty rarely useful. Horse race between let and vars. They can both. They can both win different race. Mm-hmm. Simple as that. Exactly. 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 If you see a let, you are dealing with a localized declaration. If you're dealing a var, you're dealing with a function-wide declaration. That's it. Mm. It's a bit different, and it is only useful for that loop. Hmm. Another helpful characteristic of var I have seen with declarations inside unintended block. And unintended blocks are blocks that are created because the syntax requires a block, but where the intent of the developer is not really to create a localized scope. The best illustration of unintended scope is a try and catch, not really a block scope. Mm-hmm. Fallbacks to default. There are another way to structure this scope, but yes, I think this is the best way, given various trade-offs. I don't want to declare records with var and let outside of the try block, and then assign it to in one of both blocks. I prefer initial declaration to always be as close as possible, ideally same line, to the first uses of the variables. That will only be couple of line distance, but in real code I can grow to many more. The bigger the gap, the harder it's figuring out what variables from the what scope you are assigning here. This is not really a block scope. Mm-hmm. So try and catch statements are not block scope. Okay. So that'll be all for this video. Take care. Bye bye.